Okay, so I did see this tweet. I saw this tweet, right? I saw this thing right here where it's just like, you don't use 10% of your brain, why use this? And so Bend is apparently a simple language that allows you to write, feels like Python, but also scales like CUDA. Need a sorting network? Just write a function. Vim sorter.bend. Sorting network. Oh gosh, come on. Let me see it. Need a fragment there? Just write a function. I wish I could pause this. Let's look at this for a second because this looks pretty cool. All right, so let's see. Def sort tree, case this, and this. Rots. I don't know what rots are. Hold on. DS. Okay, damn it. It looks like Python, which means there's no type, so I have no clue what the hell's going on here. D is 0. That must be depth, which is the tree. Sorting network equals just rotate trees. Okay. Tree equals XY, so that must be left and right. So this is a binary tree. Left is sort depth -1. Okay, so we're starting from the bottom. With X. S is 0. I don't know what S is. Where is S even used here? Oh, S must be is used in this rots. Right is D -1. Okay, I don't quite. Honestly, to tell you the truth, I don't really get it. I don't really get this function. There's like a warp, a down. I don't know what we're doing here. Rotate. So this must be a well-known algorithm that I know, but I just don't get it. Okay, well, it sounds cool. I just don't know how would you parallelize this? That's my question: is how is this parallelized? That's what I want to go find out. And so let's see if this thing does it, because there is a Fireship video which we'll look at here shortly. But I want to know, can I understand this from this perspective? Shaders have always just been magic to me. There you go. Here's a bunch of math. You do it on a per pixel basis, right? Dude, I've never understood. Create a pixel tree. Why is everything a tree? Are pixels trees? Create a pixel tree. Bend D equals 0 and I. Oh, is bend where? Okay, is that how you say, hey, this thing is going to be color? Go. Okay, I don't know what Go does, and I don't think it has a definition of Go. So we don't know what Go does. You need a fast map reduce? Just write a function. Okay. I mean, I love this idea, by the way, that you could just go lambda, do this one map, red, bam, 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 and you just go, and it just does it, and it makes it multi-threaded. I just don't. How does it do mutations? Because that original tree one does a tree sorting. How does it do mutations? I don't understand that. Interesting. Okay, let's go back to the GitHub repo, and because I mean honestly, this feels like V. You know what I mean? This feels too good to be true. I don't know if you've ever seen this, but whenever I see these things, it always just feels too good to be true, so I just feel like it's a lie. I'm sure that's just me being jaded, right? Because here's the thing that I don't understand is how did they make it so, whoever made this language, how did you make it so simple to be massively parallel with mutations, especially when something like Mojo is trying to do the same thing? It's totally real? Okay, it's totally real. Right? Like Mojo's attempting to do the same thing. Fearless parallelism? I know. I fear parallelism. Okay, I fear it. Mojo is different, though. Oh, I know Mojo. Of course Mojo's different, but Mojo's attempting to make Python fast as well. I know. Don't worry. We like to look at the GitHub thing, okay? It makes it more fun to start with the GitHub thing and read about it and have an idea going into it. You know what I mean? So it must be things that run on the CUDAs, right? If you want to use the C runtime, install the C compiler. Okay. If you want to use the CUDA runtime, install the CUDA toolkit. All right. Then install both HVM2 and Bend with this one. Okay. Cargo, nice. Okay, nice. Rust mentioned. Then finally write some Bend files. Okay. Uses the Rust interpreter. Wait, what? It uses the C interpreter, parallel. Uses the CUDA interpreter, massively parallel. Okay, interesting. You can also compile Bend standalone C CUDA files into Gen C and Gen CUDA for maximum performance. But keep in mind, our code gen is still in its infancy. It's nowhere near as mature as SOTA these nuts compilers like GCC and GHC. Interesting. All right, let's read about this. Parallel programming in Bend. To write a parallel program in Bend, all you have to do is nothing other than making it inherently sequential. For example, let's see, cannot run in parallel because 4 depends on 3, which depends on 2. Yes. Let's see, can run in parallel, and that can run in parallel, are independent, and it will, per Bend's fundamental pledge. Everything that can run in parallel will run in parallel. Interesting. Okay, let's look at the tree example. There we go. For a more complete example, here's that tree thing, which I just don't understand. This file implements the bitonic sorter with immutable tree rotations. Okay, so there you go. So it creates copies. There you go. That was my question. Was the copying? It is not the kind of algorithm you'd expect to run fast on GPUs, yet since it uses divide and conquer approach, which is inherently parallel, Bend will run it in multi-threaded. So the benchmarks, 16,000 threads. Oh my goodness, that's just mind-boggling. These nuts. That's a 57x speed up doing nothing. No thread spawning, no explicit management of locks, mutices. Yes, by the way, they're called mutices, which should be close. They really should be called mutalisks, okay? Because you think you like mutalisks, and you know you just can't have one. So you got to have like thousands of mutalisks. But then one effing thread lock, i.e., whatever you call those raven bombs, just destroys your entire fleet every single time. That's why it should be called the mutices. This is why. Mutalisks, mutices, same thing. It's a trap. Learn Python. Let's see. What are your thoughts on MDD, meme-driven development? Shockingly, HTMX felt like meme-driven development, and it actually wasn't. It turns out it's actually just real. It's just real development. I hate benchmarks. Generally, I dislike benchmarks because I don't know what any of these things mean. But it's cool that I like relative benchmarks, which I think relative benchmarks are very interesting. I think absolute benchmarks are stupid. Like, I wouldn't go into this thinking I'm going to get something that's super fast. What I can say is that doing nothing other than changing where you run it, it just gets faster. Because relative makes a lot of sense, because then I can compare this against this and be like, yeah, this shit's way faster. So why would you do relative benchmarks? Relative benchmarks show that long as they're comparing the output and proving that the output is sound, that you get a massive speed up, a practically 100x speed up by just swapping over into this, right? So that's really cool. But Bend isn't limited to a specific paradigm like tensors or matrices. Any concurrent system from shaders to Erlang actor models can be emulated on Bend. For example, to render images in real time, we could simply allocate any immutable tree on each frame. Okay, so I wonder what the GC's like. I would like to see more on the GC and how that runs, because I guess that's my big thing is how are they doing memory allocation? Let's see, it would actually work. Okay, so this is that demo shader, which is pretty interesting. Even involved algorithms parallelize well on Bend. Long-distance communication is performed by global beta reduction, as per the interaction calculus, and synchronized correctly and efficiently by HVM2's atomic linker. Interesting. Okay. It is very important to reinforce that while Bend does what it was built to, scale performance with cores up to 10,000 concurrent threads, its single core performance is extremely subpar. Okay, yeah. This is the first version of the system, and we haven't put much effort into the proper compiler yet. That makes sense. I think that's a great approach, by the way. Great approach right here. You can expect the raw performance to substantially improve on every release as we work towards a proper code gen, including constellation of missing optimizations. Yeah. Meanwhile, you can use the interpreters today to have a glimpse of the massively parallel programs look like from the lens of a Pythonish high-level language. This is a super promising language if this is real. I guess there's two things we could do. One, if the person who is in the chat, we could get whoever the creator is to give us like if they would like, they could give us like a 5-minute explanation of how this is accomplished and all those things, because it sounds like it's all immutable. So it works via allocations. Like you can do anything that's parallelized via allocations, if I'm not mistaken. And are the allocations, are they like RC'd? Are they all stack allocations for like the tree sorter? How does it work with heap allocations? Is it a garbage collection? I don't know. I would literally never make my own language. Is it hoarding memory? Is it a bump allocator? Just let it go straight to the universe? I do not know. Right? There's a lot of questions there that I think it mentions rendering and shaders. It does that. It does do that. Yes. Okay. So this is really cool. So let's just check out the Fireship Bend video. Okay, nice. YouTube.
Yesterday, the clouds opened up, and a weird new programming language came down to earth, with a promise of parallelism for all thou who writeth code. This is big if true, because parallel computing is a superpower. It allows a programmer to take a problem that could be solved in a week, and instead solve it in 7 days using 7 different computers. Unfortunately, running code...
I mean, that's typically how parallelism ends up happening. Parallelism is extremely hard. That's why this language is so interesting, is that it is crazy to think that there is something that could actually solve the parallelism problem. All right, it is wild. It is always on point. Banger, absolute banger meme right there.
Code in parallel is like conducting a symphony. One wrong note and the entire thing becomes a total disaster. But luckily, Bend offers hope by making a bold promise. Everything that can run in parallel will run in parallel. You don't need to know anything about CUDA, blocks, locks, mutexes, or regexes to write algorithms that take advantage of all 24 of your CPU cores, or even all 16,000 of your GPU cores. You just write some high-level Python-looking code, and the rest is magic. It is May 17th, 2024, and
it feels untrue. That's what I mean, like, because it just feels so amazing that this could possibly exist. It feels untrue. I'm curious what the rules are and how the rules are going to play. I'm also curious why. I guess I'm not too curious why it went with Python-style syntax. It just makes sense, right? If you're going to make a language like this that you want to be massively parallelized, and you want it to really, I mean, your target is going to be machine learning / data scientists, and so it makes perfect sense that it exists. That it exists in this Python. I'm curious about the edge cases, like what breaks parallelism.
And you're watching the code report. When you write code in a language like Python, your code runs on a single thread. That means only one thing can happen at a time. It's like going to a KFC with only one employee who takes the order, cleans the toilets, and cooks the food in that order. Now, on a modern CPU, you might have a clock cycle around 4 gigahertz, and if it's handling one instruction per cycle, you're only able to perform 4 billion instructions per second. Now, if 4 GIPS is not enough, you can modify your Python code to take advantage of multiple threads, but it adds a lot of complexity to your code. And
the whole thread start, thread join thing, this is just so difficult. I know this looks easy, and why is every single multi-threaded application example so simple, but every multi-threaded actual application is so dang hard? It just feels emotionally damaging every single time. Every single time you I still to this day remember my very first forays into multi-threaded programming, and it always felt so easy. It's just like, look, you just do this, and then you just join it at the end. And I'm like, that seems pretty simple. That seems straightforward. And then I actually do it, and I go, this wasn't straightforward at all, and I don't know what's happening. And now I have synchronize everywhere in my Java code. It's just the worst. It sounds like skill issues. It is skill issues because it's effing hard. I don't have the skills to pay the bills on threads, okay? And debugging is awful. Debugging is always awful. Ugh.
There's all kinds of gotchas like race conditions, deadlocks, thread starvation, and
deadlocks are still completely available in async await. The Rust async await, because Rust async await is pull versus JavaScript's push. You run into deadlocks because you don't know what you're doing. The worst part is especially in Rust, if you have an error that you just simply want to ignore, you just simply assign it to underscore. The problem is that as you're programming and then you change the API to a wait or to an async function, and then you don't realize that your underscore assignment also will ignore async, and it won't give you a warning, and then you just explode. You have no idea why, and you're deadlocking for days, and it's just like, oh man, that is just just the worst. It's just the worst. For those that don't understand it, it's the main RS, right, where you have something that looks like this. What is it? Funk main me daddy, and then you have something like async fn foo that returns a result. I don't know. Why not? There we go. And it does this. And I don't even have an LSP, so I don't even know why it's doing this. Right? So we'll just go like this. Okay. Right? There we go. We return that. And you do foo. There we go. So by doing this, it's going to call it, and it's going to just simply ignore the fact that this is a future. And you have to await it. If you don't await a future, it don't work. And so it's like that will just simply ignore it. And so I've had so many times in my life where I was programming something, realized I need to go to async because, again, every single time you're in the world of async, you have this whole problem, which I think we all know about this whole problem, but just to make sure we all do, we go to Ryan Winchester's profile and look at his pinned tweet right here. You have this whole problem where you have all of your functions come together. One of them's async, and now you got all of them async. All of them become async immediately. You forget you've done that. You've ignored an error, and boom, you've now just ignored an async call, and now your async call never runs, and then you're emotionally bruised every single time. Every single time. Oh my goodness, I just hate it. Anyways, it's happened once before. That's why I actually never ignore errors now. The underscore assignment was a mistake. I think it was genuinely a mistake in Rust because it can lead you into this. Why don't you just have all your functions be async? Shut up, Marcos!
red starvation, and may even lead to conflicts with daemons. Even if you do manage to get it working, you might find that your CPU just doesn't have enough juice, at which point you look into using the thousands of CUDA cores on your GPU. But now you'll need to write some C++ code and likely blow your leg off in the process. Well, what if there's a language that just knew how to run things in parallel by default? That's the promise of Bend. Imagine we have a computation that adds two completely random numbers together. In Python, the interpreter...
You can tell he's a man of culture, okay? You can just see the man of culturing right here. Totally random numbers. Completely random, culturally appropriate numbers.
Together. In Python, the interpreter is going to convert this into bytecode and then eventually run it on the Python virtual machine. Pretty simple, but in Bend, things are a little more complex. The elements of the computation are structured into a graph, which are called interaction combinators. You can think of it as a big network of all the...
This guy writes Haskell. You can just tell right away, zero information about the person. But from the GitHub, said the word calculus, and I didn't see any integrals. And then also here, we see the word combinator. Again, this is Haskell mentioned. This is Haskell mentioned, for sure. This is Haskell mentioned. Pick has been here. Big fan here, thank you. White papers mentioned. The white papers are happening as we speak.
Computations that need to be done. When two nodes run into each other, the computation progresses by following a simple set of rules that rewrite the computation in a way that can be done in parallel.
Okay, so if you're tip to tip, you become infinity. But if you're tip to tip fully colored in, you become two lines. But then if you're tip to tip, but one's only full, then you become definitely the infinity sign, just poorly drawn. I don't know what this means. I don't know.
It continues this pattern until all computations are done. It then merges the result back into whatever expression was returned from the function. This concept of interaction combinators goes all the way back to the 1990s and is implemented in a runtime called the higher order virtual machine. HVM is not meant to be used directly, and that
it is above your pay grade. I must say that at this point in programming, since I've never been a big lambda calculus dork, I just don't understand these concepts or even the vernacular behind it. It's like that guy that doesn't have compiler experience and walks in and keeps calling everything a compiler when it's a transpiler, but then when you actually get around people whose like job it is to write these things, you know how vernacular bothers them when you use it incorrectly? For me, I'm just like, lambda calculus, what the shit is this? Right? And they're like, well, you're not using the terms right, you know? And people understand, like people will start being like, I can tell you're new, and you can tell I'm new because of that.
HVM is not meant to be used directly, and that's why they built Bend, a high-level language to interface with it, and the language itself is implemented in Rust.
You can tell right away that's why it's so good.
Syntax is very similar to Python, and we can write a hello world by defining a main function that returns a string. Now, to execute this code, we can pull up the terminal and use the bend run command. By default, this is going to use...
That's single-threaded Rust interpreter, correct? Yeah.
Use the Rust interpreter, which will execute it sequentially, just like any other boring language. But now here's where things get interesting. Imagine we have an algorithm.
Why aliens? Why aliens pre-watch? Come on. It's because I read the GitHub. This is why we read the GitHub first, okay? Because the next one is then if you build it with a C, you get to run it on all of your little nodes. And then if you build it with the CU, the CUDAs, you get to run it on all your CUDAs.
Get interesting. Imagine we have an algorithm that needs to count a bunch of numbers and then add them together. The first thing that might blow your mind is that Bend does not have loops. Like, we can't just do a for loop like we would in Python. Instead, Bend has something entirely different called a fold that works like a search and replace for data types. And any algorithm that requires a loop can be replaced with a fold. Basically, a fold allows you to consume recursive data types in parallel, like a list or a tree. But first, we need to construct a recursive data type. And for that, we have the Bend keyword, which is like the opposite of fold. Now, if that's a little too mind-bending, maybe check out my back catalog.
Okay, so I actually got lost in the sauce there for a second. I'm not gonna lie to you. I feel like Mark Cuban right now, and being like, "Oh, you said fold, therefore I'm out." And I'm not gonna lie to you. When I saw all those cans going, might have got a little distracted by the cans, as opposed to what was actually happening. Okay, so a fold, I feel like I get. A fold is just a function that produces out. A fold is just reduce for those that are just JavaScript kiddies. That's all it is. Fold is just simply reduce, and this is like your seed value typically is the one right here, and then you like go up it, right? It's just going over a list, reducing it. I believe they use the term catamorphic operation. It takes something that is a list-like structure and reduces it one level. So if you had a list of lists, it should produce a list at the end. So you could double fold on it. You could double fold it. You can fold and bend. And so the bend must be the opposite thing. The bend is a value that goes into a list. I'm not, see, that's where I start losing it. You can't use wrinkle brain vocabulary on Twitch. You really can't use wrinkle brain vocabulary
Loop can be replaced with a fold. Basically, a fold allows you to consume recursive data types in parallel, like a list.
A recursive data type, yeah, just like a list. It's something that you can walk across via recursion to get to the end of. Okay, which means you could also use a tree. You could also use a graph with a DFS. Okay, I think we're starting to see it. Confirmed, pick was a mistake. Confirmed, pick is a mistake.
List or a tree. But first we need to construct a recursive data type, and for that we have the bend keyword, which is like the opposite of fold. Now if that's a little too mind-bending, maybe check out my back catalog for recursion in 100 seconds. But now let's see what this looks like from a performance standpoint. When I try to run this algorithm on a single thread, it takes forever, like 10 minutes or more. However, I can run the same code without any modification whatsoever with the bend run C command. When I do that, it's now utilizing all 24 threads on my CPU, and now it only takes about 30 seconds to run the computation. That's a huge improvement, but I think we can still do better. Because I'm a baller, I have an NVIDIA RTX 4090, and once again, I can run this code without any modification on CUDA with bend run-cu. And now this code only takes 1.5 seconds to run, and I'll just go ahead and drop the mic right there. This has been the Code Report. Thanks for watching, and I will see you in the next one.
Very cool. Okay. So this looks totally awesome. And I absolutely think it's fantastic. But I do want to say something, okay? I'm going to say something. And I hope that you guys don't get upset at me. Everyone virtually in this chat will never use this language. Let me tell you why this is the case. This is the case because this language is specifically designed for people that have what we refer to as an adult education in mathematics, okay? Most of you guys are a bunch of front-end Andes writing React. Like, this isn't going to come to the front end and be useful like that. This isn't going to come into your server and be just instantaneously useful on your server, okay? This is just going to be useful for people performing like linear algebra and all that stuff, and they just want fast Python. They want loops that don't suck ass, and that's called pandas, or it's called this, whatever this is, okay? I don't use it either. This isn't going to be useful for me either, okay? It's absolutely super duper awesome, and the speed and the glory of it is fantastic, and the fact that you can use the term calculus and not use an integral at the exact same time makes it just mind-blowing for me, okay? I don't get it, but here we are. Here we are doing these things, and it just feels fantastic. It feels amazing. When you look at this language, you think, how could this not be the language we all use? This is truly the Lord's language. It requires folds and bends and shit in reality that does not make any sense, and yet here we are realizing that all we're going to be doing is writing simple stuff on the front end or the back end, and it's just not going to be for you. It's not for you. It's not been for you. It will not be for you in the future, so just be okay with it, okay? Instead, learn Rust, learn Go, learn JavaScript, learn OCaml, learn Elixir, learn Swift, and enjoy your day, okay? The name is, I'm sorry, but this is fantastic, but at the exact same time, you'll probably never use it again. But by the way, there will be people that do use it, and they will love it, and it'll be fantastic. Just not for your use case, okay? Just probably use Elixir or something like that.